So let's just start with the topic, or the very first topic of this chapter, which is nothing but the surface area of a combination of solids. So let us suppose if I'm just taking that previous container again, which was fitted on the tank, and if I'll just take that particular container, then I can see that if I'll divide that particular container in such a formation, then it can be seen like this. As you can see, this was the container. In the combined form, we can see this was the container actually, and if I'll divide this particular container into a form of a cylinder and the two hemisphere, then we can see that this particular container is actually nothing but a combination of these solids. Now let us suppose if I'm just talking about finding out the surface area of the combination of this solids, then I can see over here that the TSA of the solid, of this particular solid, is actually nothing but is equal to the CSA of one hemisphere plus the CSA of a cylinder plus the CSA of another hemisphere. You can see all by yourself. If I'm just talking about the TSA of this particular new solid, then this is nothing but the CSA of this hemisphere plus CSA of this cylinder plus the CSA of this hemisphere, which is another hemisphere. So what is TSA and CSA? So TSA is actually nothing but called as the total surface area, and the CSA is nothing but called as the curved surface area. So you can see all by yourself. If we just wanted to find out the surface area of such kind of combination of solid, then we can find them out by dividing them into certain solids that we already are aware about. For an instance, this was the container that was actually present to us, and we have divided this container into such a formation in which we know about the surface area of all the solids that are present. So in this particular formation, we can find out the surface area of the combination of the solids. So let's just see an example which is related with it. Let us suppose if I am just talking about an example which says that a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere. So actually a toy, it is of the form of a cone, and it is mounted on a hemisphere. So let us suppose if I'll just make a figure for this one, so I can see the toy is actually of this form. You can see over here that there is this hemisphere, and there is a cone which is mounted on this particular hemisphere, and it is of the same radius as per the question. It says the total height of the toy, the total height of this particular toy is actually nothing but 15.5 centimeter, and the question arises is find the total surface area of the toy. So we just have to find out the total surface area for this particular toy. So let's just start finding out the answer for this one. As we can see, this is nothing but a combination of two solids. We can see all by ourselves that it is nothing but a combination of two solids. The very first one is nothing but a cone, and the second one is nothing but a hemisphere. So if we can find the surface area of the two of the solids, by combining both of them, we can able to find that out the TSA of the toy in whole. So let's just start with first of all the things that are given to us. As we can see, the radius is given to us as nothing but 3.5 centimeter. So let us suppose if I'm just taking this radius as nothing but r, if I'm just taking this as r, so we can see over here that according to the question, let us suppose if I'm just starting the solution set of this particular question by taking or assuming the radius. So let the radius being r is actually nothing but is equal to 3.5 centimeter. We are aware about that the radius of this particular cone is nothing but 3.5 centimeter, and the radius of the hemisphere is also same. Now further we can see over here that the height of the total toy, so we can see the height of this particular total toy is actually nothing but 15.5 centimeter. So if I'm just talking about its height, so this is total of, so let us suppose if I'm just talking about the height of this toy, so this is nothing but 15.5. This is nothing but 15.5 centimeter. So this is 15.5 centimeter. And now as you can see, if I'm just talking about this particular hemisphere, so we know that if this radius is nothing but if this radius is 3.5, so it means that this particular this particular portion over here is again nothing but 3.5 centimeter. So if this is 3.5 centimeter, the hole is 15.5 centimeter, then we can able to find out the height of this particular cone, obviously. So let us suppose if I'll write it over here, that the height of the cone is nothing but is equal to 15.5 centimeter minus of 3.5 centimeter, which is nothing but is equal to 12 centimeter. So hence we are aware about the height of the cone, that the height of the cone is nothing but 12 centimeter. Now let's just talk about finding out the surface area of the hemisphere first of all. So we know that the surface area of a hemisphere is nothing but is equal to 2 pi r square. It is 2 pi r square. So this would be 2 into pi. Let us suppose if I am taking the value of pi as 22/7 over here into r. We know the radius is nothing but 3.5, which is already given to us. So this is 3.5 whole square. So let's just sort it out. This is 2 into 22/7 into 3.5 means 35/10 into 35/10. So let's just sort it out again. This is 7 and 5 is 35. Then again we have 5. Let us suppose I'm just taking it 5 and 2. So 2 and 2 get cancelled with each other, and further we can say, let us suppose if I'm just cancelling out the value over here as nothing but 5 and 7, 5 and 2 is 10. Again further 2 and we have 2 and 1 and 1. So this is nothing but 11 and 7. At the end we are getting 11 into 7, which is nothing but 77 centimeter, since we have the units as centimeter. So we have the surface area of the hemisphere as nothing but 77 centimeter square. So this is the first surface area that we have, which is related with this particular toy. Now let's just talk about the cone, because we already know the surface area of the hemisphere is nothing but 77 centimeter square. Let's just move on further with finding out the surface area of the cone. So in order to find the surface area of the cone, we just have to find the CSA of the cone. So let us suppose if I'm just talking about the CSA. We all know what is CSA. CSA means the curved surface area of a cone. So the curved surface area of the cone is actually nothing but is equal to pi RL. This is pi RL. So in order to find the CSA of the cone, we have to find out the value of L. That is nothing but called as the slant height. So let's just find the slant height of this particular cone. So we know about a relationship in between the slant height, radius and the height as, let us suppose if I am just finding out the slant height and I'm just putting it under a box. Let us suppose if I am just finding out the L value first. So we know that there is a relationship that L square is nothing but is equal to R square plus of H square. We already know about this particular concept. Now let us suppose if I'm just substituting all the values over here. This is the radius. We already know that the radius is 3.5 whole square plus the height. We know that the height is nothing but 12 square. We know that the height of the cone is 12 square. So L square is nothing but is equal to 3.5 whole square plus 12 square. Now let's just talk about the height. Since we know about the height as nothing but 12 centimeter. You can see all by yourself that the height is 12 centimeter and this is 3.5 whole square the radius. Now let's just sort it out further. So if I'll sort it out further, this would be nothing but L square is equal to, you can see this is 3.5 whole square. If you'll sort it out, you will get the answer as nothing but is equal to 12.25 plus of, we have 12 square, which is nothing but 144. We have 144. Now let's just add it up. This would be nothing but is equal to, this is 156.25. This is 156.25. So it means that L is nothing but is equal to square root of 156.25. So if you will just find out the square root of this particular number, that is 156.25, you will get the answer as nothing but 12.2. Let us suppose if I am just taking the square root of this one. So the square root of 156.25 would become as 12.25. If we just take the square root of this one, this number 156.25, which is related with the slant height of this, is nothing but So it means that L is nothing but is equal to square root of 156.25, and further if you sort it out and take the square root of 156.25, you will get the answer as nothing but is equal to 12.5. So hence the slant height is actually 12.5. L is nothing but called as the slant height. So the slant height is 12.5. Now let's just plug in the slant height into the CSA of the cone. Now we can see the CSA of the cone is actually nothing but is equal to pi RL. So pi is 22/7, the radius is 3.5 which is given to us, and the slant height is nothing but 12.5. This is 12.5. Now let's just sort it out further. So as we can see, we have the values as nothing but 22/7 into 35 divided by 10 into 125 divided by 10. So this would be nothing but 7 and 5. We have 5 and 2. We have 2 and 11. Further we can sort it out as 5 and 2 we have, and 5 and 2 into 10, and 5 and 5 is 25. So we have the value as nothing but 11, and further we have the value as nothing but 25, and further you can see that we are getting the value at the end as nothing but by 2. So let's just multiply both of these values over here. So you can see 25 into 11. Let's just multiply 25 and 11. So we have this as 5 and 2, and further we have this 5 and 2. So we are getting the value as 2 and 7 and 5. So 275 we are getting at the end. So this is 275 divided by 2 centimeter square, because the units that we have is nothing but centimeter square. So we are getting the CSA of the cone as 275 centimeter square. So let us suppose if I am just calling this as nothing but the equation number 2. So we have to find the TSA. We have to find the TSA of the toy. So let us suppose if I am just finding out the TSA of the toy. So the TSA of the toy is nothing but is equal to the surface area. The surface area of the hemisphere, plus the surface area, curved surface area of the cone. So this would be nothing but is equal to the addition of the first equation and the second one. So this is 77 plus of 275 divided by 2. So let's just take the LCM. So as you can see, this would be nothing but 154 plus of 275 divided by 2. Let's just sum it up. So this would be nothing but 9, and we have 12, and this is 2, 3 and 4. 429 divided by 2. You can see this is 429 divided by 2, which is coming up. Let's just sort it out further. This would be nothing but 2 into 2 is 4, 2 into 1 is 2, 2 into 4 is 8.5. So this is nothing but 214.5 centimeter square, and this is nothing but the answer for this particular question, in which the TSA of the toy is actually coming out to be equal to 214.5 centimeter square. So this is how you can find out the surface area of the combination of the solids that are in this particular formation.